Hey everyone, welcome back to a new episode of Are You Ready for Calculus? This is a series of short videos where I give you bits and pieces of information that will hopefully help prepare you as you enter Calc 1. Now, let's be honest, there is no way to fully prepare for the amazing, mind-blowing things that you are going to learn in calculus class this year. But as I said, I want to give you bits and pieces of information, a lot of algebra and trig, to help you feel just a little bit more confident as you go into the class. In this episode, I want to talk about something that a lot of people love, but also a lot of people hate, and that is factoring. Before we jump into some examples, I want to mention that, factoring can be considered the process of undistributing. As you see here, distributing would be multiplying x plus 2 and x plus 3. And when you do that, some of you might know that as FOIL. I just like to call it distributing, though. You would end up with x squared plus 3x plus 2x plus 6. But then when you combine the 3x and the 2x, you get this 5x that you're seeing here. Okay, hopefully if you're familiar with that, if you need to, review that a little bit, good news, you will see some of that in the examples that I do. Okay, but what we're going to mainly focus on here today in this video is doing the process backwards, meaning if I give you x squared plus 5x plus 6, could you tell me that the factors are x plus 2 and x plus 3? Okay, so let's just jump straight into some examples. Take a look at these 6 examples. The directions are pretty clear. You are just supposed to factor. Okay, but factoring could mean a lot of different things. It could mean finding the greatest common factor and dividing that out to get your factors. It could mean factoring a trinomial into 2 binomials or unfoiling. Some teachers say that. I really don't like that, but it's out there. It could be a combination of those things, or there's all sorts of different, factoring techniques that I'm sure you have learned in your algebra classes. Okay, let's take a look at part A. What we have here is 4x cubed plus 8x squared, and for this one, I would recommend we start by thinking about a greatest common factor, right? Because there are 2 terms here, and both of them have x's in them, so there's definitely common factors. Okay, the greatest common factor, or we call that GCF. What color is my pen? I don't even remember what color. It's blue. Okay, that's a good starting point. I like blue. GCF, the greatest common factor, is the monomial that can divide into both terms of this binomial. And so that would have a 4 in it, right? Because 4 and 8 are both divisible by 4 and no other higher number. Okay, and also there's going to be an x squared in it, right? Because you can divide out an x squared from both of these terms. So our GCF is 4x squared. Okay, so what we do to set up our factors is we write the greatest common factor, 4x squared, in front of a set of parentheses, and we think about what would be left if we would divide 4x squared out of both of these terms. Or you could think of this as undistributing the 4x squared, meaning what should you have here so that when the 4x squared would be distributed, you would have 4x cubed. That would just be x, right? 4x squared times x is 4x cubed. Next term, if I have a positive 8x squared, what do I want to put right here? Well, definitely a positive number, right? Positive something. So that when a 4x squared gets multiplied with it, I'm ending up with 8x squared. That would just be 2, right? Or in other words, 8 divided by 4 is 2. And these x squareds are not here because they're over here. Okay, hopefully that looks familiar. That's something that will probably come up a lot, especially if you're in an AP Calc class, factoring by GCF. Okay, in the next example, let's pick a different color. What color do you want to go with, as though I can hear you? Okay, let's go with green. We are going to, I don't see a greatest common factor because there is only a coefficient of 1 here in the first term. The last term does not have any x's in it, so there's no GCF this time. What we're going to do with this trinomial, 1, 2, 3 terms, is we are going to factor it into 2 binomials. Go straight into this type of factoring, which probably looks really familiar because this is what you spend a lot of time on in Algebra 1 and Algebra 2. If you took like a pre-calc or a college algebra class, you probably did a lot of this too, right? So hopefully, this will come back quickly if you forget it or if you have forgotten it. What do I need to do here? I need to put an x for each of these binomials because x times x gives me the x squared. And then I need to put two numbers that will multiply to get 80. And those two numbers also need to add or have a sum of negative 18. Okay, so the only way I'm going to do that is with two negative numbers, right? A negative multiplied with another negative is a positive, but when you add two negatives, it stays negative. So what are those two numbers? Well, in algebra class, I typically make my students list all of the different factors of 80. My dog is here. I don't know if you can see her in the camera, but she might pop through. It's fine. I don't even care. I love her. Okay, but yes, sure she is. Okay, go play. Go play. All right. This is great. She's gonna do some math with us too. I can't get her to go away. Oh geez. Okay, I'm back. I had to distract her. Okay, I'm not even gonna edit it out. It's fine. Okay, we need two numbers that multiply to get 80 and add up to negative 18. I'm not gonna list them all to save you some time. If you want to pause and do that, you can. But the numbers are negative 10 and negative 8, right? Negative 10 multiplied with negative 8 is positive 80. Negative 10 plus negative 8 is negative 18. And what I want to do now is distribute these. I did not talk about doing that in this one, but I kind of did. I just didn't write it out. I'm going to distribute this through to show you why it works, just in case you need to see that. So if I distribute the x to the two terms in the second set of parentheses, I get x times x is x squared minus 8x. And then when I distribute the negative 10 through the two terms in the second set of parentheses, I get negative 10x and plus 80. Remember, distributing means multiplying. So that's why I have x squared minus 8x minus 10x plus 80. When I combine these two middle terms, because they are like terms, I'm running out of room, but I think that we can agree that we would get negative 18x from that, right? So you might know this as foiling. That's what it's very commonly called. I just call it distributing, though. And that's just a way that you can check your work. The answer to the factors are in green. The red is just sort of checking it to make sure that it works. I ended up with what I started with here. All right, let's move on to another one. Let's pick purple as our color this time. I really like the color purple, but I'm not a purple person. I don't have a lot of purple in my life, but I like to write with purple. Okay, so for this one, I see a coefficient of 2, and I notice that the other two terms are also divisible by 2, so there's a GCF there. The GCF, in this case, greatest common factor, is 2. So I'm going to first divide out a 2 from all of these terms. 2x squared divided by 2 is x squared, plus 20x divided positive 20x divided by 2 is positive 10x. And negative 48 divided by 2 is negative 24. Now from here, I am going to, I'm going to get a little bit nervous because, maybe I'm done. I was like, I don't know if we can keep going from here. Yes, we can. Nope. Okay. I didn't do an answer key to this. I just grabbed this and started recording. We can keep going. I was like, there are not numbers that multiply to get negative 24 that also add up to 10, but there are. Okay, so we need to do another step here. We are combining. Okay, I got distracted again by my dog. Sorry, I had to pause it. All right, what was I saying? Let's keep going. Okay, we can bring down the greatest common factor of 2, and we can factor x squared plus 10x minus 24 into binomial factors, again, starting with x's in the front. Okay, if you're thinking, I don't know what numbers multiply to get negative 24 and have a sum of 10, I would suggest you list them all out. And this time you are going to want to consider one positive number and one negative number because that's the only way you are going to get a product that is negative. So we need a positive number and a negative number. Can you figure out what it is? Factors of 24, like 1 and 24, 2 and 12, 3 and 8, 4 and 6. So you should be thinking about like -1 and +24 or vice versa. -2 and +12. There it is, right? +12 minus 2 gives us +10. I'm not going to spend time distributing this one through because I don't have a ton of room, but if you would like to pause and try that for yourself, what you would do is you would first distribute the x plus 12 to the x minus 2, or you would FOIL these binomials, and then you would multiply your result by the 2, and what you should get when you're all done is 2x squared plus 20x minus 48 to confirm that you have the correct factors. Okay, I'm going to move down here to one of our, maybe we want to call it like a special case, I don't know. What we have here is x squared minus 16. Okay, this is a binomial that does not have a greatest common factor. So what are we going to do to factor it? Well, you have this special case called difference of squares, right? Where if in your binomial you have two perfect square terms, and what you see in between them is a minus sign, then you can factor by difference of squares. Also, you could think of this as like factoring a trinomial, where you need the numbers that you're going to come up with in your binomials to multiply to get -16 and add to 0. Okay, like this. X times x is x squared. I need numbers that multiply to get -16, but I need them to have a sum of 0. The only way I'm going to do that is with the square root of 16, which is 4, and one of each sign. +4, that doesn't look good. Let me fix that. +4 and -4, right? 4 times -4 is -16, but 4 minus 4 is 0. Let's go ahead and FOIL this one. I just said FOIL. Distribute this one, FOIL, whatever. X times x is x squared. X times -4 is -4x. 4 times x is +4x. And 4 times -4 is -16. Those middle terms have a sum of 0, don't they? -4 plus 4 goes to 0. So what I'm left with is x squared minus 16, which is what I started with, and that's how I know that I'm good. Again, the answer, the factors, is what is in gray here. I never finished my little arcs, did I? Sorry, I'm thinking about my dog now. All right, the red that I have here is just the check. Okay, let's keep going. Couple more examples. E is going to look real weird, right? Like, what is going on there? But actually, believe me, when you do what is called implicit differentiation in calculus, this will be helpful. You'll see things with the letter D in them, believe it or not. Okay, but what we're going to do here is every term has a D in it, so that's our GCF. And we're going to divide that out of everything like this. And that's the only thing that we can do here, right? This is not your typical trinomial. We don't have an x in the middle. We have a y. So that is it. That is the answer to the factored form of the expression that you see in part E. Okay, and finally, one more. I'm kind of running out of colors that work. Let's go with this color. This is another one where we're going to have two steps. The first step is we're going to factor out a greatest common factor. And in this case, that is 25. What else do these have in common? An x, right? Only one x because this second term only has one to give. So let's put that GCF in front of a set of parentheses. Whoops, 25x. And let's write what would we have left when we divide that out. The first term would end up as an x squared, right? 25x times x squared is 25x cubed. What's the second term? 100 divided by 25 is 4. Negative 100 divided by 25 is -4. And that's it, right? Because we took the x out, we divided the x out here. But do you see what you can do next here? You have one of these special cases again, a difference of squares. Let's bring this 25x down and let's do two binomials. That would end up being x plus 2 and x minus 2, right? And if you want to FOIL that out, I said it again, FOIL, to see that you end up with x squared minus 4, go ahead, but I'm just going to put a box around this final answer. Okay, if you followed along with all of this information, then you're in a really good place for knowing all of the different factoring that you're going to need to do in calculus for the most part. The last thing that I have for you are just a couple of little other pieces of information. For example, I didn't talk about any trinomials where the leading coefficient doesn't end up or isn't 1 or end up as at 1 after you do a GCF. So maybe we should talk about this real quick. And what I actually want to talk to you about is two things. One of them is if you see something like this where you do not have just a coefficient of 1 in front of your x squared, you could try to jump straight into factoring into your binomials by doing like guess and check. Okay, the difference between this and what you were doing here or here is you can't divide this 8 out in front of the x squared, so you would have to say, well, maybe it could be 8x times x. Maybe it could be 2x times 4x, you know, and then do factors of 3, 1 and 3, both negative, and, you know, keep FOILing to see if that works. Keep distributing to see if that works. But also, there's this kind of weird method, and I don't really know if this is exactly the AC method that some of you may have learned, but I saw this method on TikTok, so I'm going to show it to you real quick just in case it's helpful. Okay, so what I'm going to do is I'm going to take this 8 and I'm going to multiply it over here. Okay, this is a weird process, but just try to bear with me, and if you don't want to do this ever again, you don't have to. But what we're going to do is have an x squared minus 10x plus 24 as our trinomial. Because again, what I did was I moved this coefficient of 8 over here and I multiplied it with a 3. Now I'm going to factor this, okay? And this is a much easier one to factor just by thinking about it because I have just x and x here. I need numbers that multiply to get 24 that add up to negative 10. Those would both be negative numbers. And what would they be? Negative 6 and negative 4, right? Negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. Okay, that's not my final answer, though, because remember, I moved this coefficient of 8 over here. So what I now need to do is I need to divide these two numbers in the back by that coefficient of 8. Reduce the fractions. 6 over 8, what's that? 3/4? 4 over 8 is a half. And then move the denominators of those fractions in front of the x, like this. 4x minus 3 and 2x minus 1. So do you see what I did there? I took this 4 and I took it out of here and I put it there. Say you multiplied this by 4. Okay, and I took this 2, this denominator 2, and I put it here. You could say that you multiplied this by 2. So you're bringing the 8 back just as a 4 and a 2. And it works. It works. Watch this. I'll scroll down a little bit. Let me grab my red to check. If I distribute the 4x through the 2x minus 1, I get 8x squared minus 4x. If I distribute the negative 3 to the 2x minus 1, I get negative 6x plus 3. And when I combine my like terms in the middle, I end up with 8x squared minus 10x plus 3, and that's what I started with. So this is the correct answer. Okay, I will highlight in blue or box it in blue. What is the correct answer? This is just the little crazy method I did to get there. And then my check. I think it's kind of cool. I probably won't use it very much beyond this video, but still, I wanted to share it with you. Okay, and then finally, I would like to mention that it might be a good idea to know your difference of cubes formula. Um, to be honest though, like in the curriculum that I teach, this comes up like one time and that is it. So I don't want this to stress you out too much. But again, you might see it here or there. You're going on to other, advanced math classes beyond Calc 1. It might be a good little thing to have in the back of your mind that there is this formula out here because it could come in handy. Okay, so an example of this, like the place that I know that I see it in my curriculum is we have within a limit. I don't need you to know what that is yet, but at some point we see a limit with an x cubed minus 1 in it, and we do need to factor it when we complete that limit. And so I would use this format. You may have learned this as SOAP, same, opposite, always positive. I don't know. Don't worry if you haven't ever heard that before. It's okay. You're going to be okay without it. But what I would do here is this is x cubed minus 1 is the same as 1 cubed, right? So the a is x and the b is 1. So I would have here x minus 1 for the a minus b part. And then I would have, what would I have here? X squared plus 1x, AB, 1x, or just x, plus 1 squared is still 1. And so the factors of x cubed minus 1 are x minus 1 and x squared plus x minus 1, or plus 1. Again, not going to make or break your experience in calc, but, I wanted to throw it in there for good measure. Okay, everybody, this is the end of this little video. As usual, I hope it was helpful. And if you want to know more, check back to the channel soon. Bye.